So in this video we are going to be looking at the factor theorem and how we can use it to help solve questions that involve certain polynomials and division of polynomials. Now the factor theorem is very simple. Basically it says that if f over a equals 0, then x minus a is a factor of f of x. And if f of b over a equals 0, then ax minus b is a factor of f of x as well. So for example, what that means is if f of 2 equals 0, then x minus 2 is a factor. If f of minus 7 equals 0, then x plus 7 is a factor, i.e. x plus 7 divides into f of x exactly, with no remainder. So let's just take an example. I've got f of x is 4x cubed minus 8x squared minus x plus 2. Now what I'm going to do is I'm going to take f of 2. So I'll calculate that and do 4 times 2 cubed minus 8 times 2 squared minus 2 plus 2. So 2 cubed is 8, that would be 32. I take off 32, I take off 2 and add 2. I indeed get 0. That means that x minus 2 would divide into this exactly. I'm just going to write it over here. X minus 2 would divide into that exactly. Similarly, if I take f of 1/2, I do 4 times a half cubed minus 8 times 1/2 squared minus a half plus 2, and when you calculate it again you get 0. Now what that means is if it's f of a half, if you think about when you're solving a quadratic, if you had this, 2x minus 1, and you put it equals 0, that would give you x equals a half. That's exactly the same thing as we've done here. So 2x minus 1 is my other factor. Those are my two factors, so x minus 2 and 2x minus 1. Now let's just prove that. What we're going to do is we're going to prove it by long division. What I'm going to do is I'm going to divide this by x minus 2. If I get 0 as the remainder, that means that x minus 2 is a factor. So let's put x minus 2 in. Don't forget with our long division that we have to line everything up exactly. If you need to, go back and watch the other video I've done on long division. X goes in 4x cubed and 4x squared times. Then you multiply it back, that gives me 4x cubed minus 8x squared, which is great because that means they both cancel. When you subtract them, I get 0. I'm going to bring it down. So I've got minus x, so I do minus x goes into that minus 1 times. I have a 0x there. So we've got minus x and plus 2, and when you multiply it out, you indeed get minus x plus 2. So the remainder, this bit here is the remainder. That gives me 0. Okay, so what I can say is that this function here, f of x, equals, you've got your x minus 2, and I have 4x squared minus 1. So this is definitely a factor. But actually, from this, I could probably find the second factor as well. We expect there to be either 2 or 3 factors, just because it's a cubic. It's very unlikely to have one factor. And this is the difference of 2 squares. So that will give me my 2x minus 1 that I need. And my final factor would be 2x plus 1. So from this, I can see what my 3 factors would be. 2, a half, and minus a half. And that's basically what we've now proved the factor theorem, sort of. We've proved that x minus 2 is definitely a factor because I've divided it through exactly. Let's take an example. Let's take a typical question. Now, what you'll probably have to do is use the factor theorem and maybe a combination of factor and remainder theorem, which we'll cover next lesson, to solve certain questions. This is a very easy example. So I'm going to take x minus 3 is a factor of f of x, which is 3x cubed plus kx squared minus 5x, plus 6. Pause the video, try and solve it. What I want you to do is find k. Try and solve it now, okay? I'm going to go through it right now. X minus 3 is a factor, which means that f of 3 equals 0 by definition. So what I'm going to do is I'm going to take 3 and I'm going to put it into here. And I have, therefore, an equation that I can solve for k. So I get 3 cubed plus k times 3 squared minus 5 times 3 plus 6. 3 times 3 cubed is 3 to the power of 4, that's 81. 3 squared is 9 minus 15 plus 6, and that equals 0. So when I rearrange that, I get that 9k equals 72. Divide through, I get k equals 8. It's a very basic example. It's very simple. What you'll more likely have happen is you'll get two separate factors and you'll have two unknowns, and what you'll have to do is create simultaneous equations to solve them. This can either be two factor theorems, or it could be one factor and one remainder theorem, or possibly two remainder theorems as well. But it all applies exactly the same. X squared plus 4x minus 5 is a factor of, so we'll take f of x is 2x cubed ax squared bx plus 5. Now, I'm just going to rub the top bit out. What I'm going to do first of all is, I don't know what the individual linear factors are yet, but I could factorize this. If I factorize it, I get that. If this is a factor of this, then this and this is a factor of this as well. So what I want to calculate is, this bit gives minus 5, and that bit gives plus 1. So I'm going to calculate f of minus 5, and then f of 1. And those have to equal 0. F of minus 5, when you calculate it, is, if you put this in here, minus 250, 25a, minus 5b, plus 5, and that will equal 0. So from that, what I can get is 25a minus 5b equals 245, or when you divide by 5, I get 5a minus b equals 49. And I'm going to put that in a box. I always recommend this, especially with these questions, they get quite long. When you have simplified down to your first simultaneous equation, put it in a box, label it number 1, whatever you do, just make sure you put it in a box so you can make sure you can find it, basically. The next one is f of 1. This is my second one. This one's a lot easier. 2 plus a plus b plus 5. When it's f of 1, you can just look at the coefficients. The x's effectively just disappear. If it's f of 0, you would just cancel it and see the number. So we get 2 plus a plus b plus 5 equals 0, and therefore a plus b equals minus 7. And that is my second equation. I'm going to rub everything out and put it at the top, so if you need to take any notes, just pause the video now. So my two equations were 5a minus b is 49, and a plus b is minus 7. So very simply, we add them together, because they're simultaneous equations, the b's will cancel. If you need to, you might need to do some multiplication here, just to get the coefficients to cancel. Add them together, you get 6a equals 42, and therefore, I'm going to put it up here, a equals 7, put it in a box. Substitute a equals 7 into either of these. Obviously, the second one is easier than the first, so I'm going to put it in here. A is 7, so 7 plus b equals minus 7, and therefore b equals minus 14. Now, just like a GCSE, you do need to check. Okay, if you check, it makes it a lot easier. So, put it into this one. 5a, so 5 times 7, which is 35, minus minus 14, so I add 14. If this gives me here 49, which indeed it does, that means it's correct because I need 49. Okay? If you don't double check, you are potentially costing yourself some marks, especially at Add Maths. That will then cost you an A star very easily. Okay? Make sure you double check, you guarantee yourself your full marks in the exam.